The night sky spills across the void like a living tapestry of fire and silence. Galaxies unfurl in slow, eternal spirals, their arms glowing with the light of ancient suns. Against the backdrop of infinite darkness, a quiet storm brews, one invisible to the naked eye, yet more powerful than any supernova. Down in the depths of existence, far beneath the reach of telescopes and cosmic lenses, subatomic particles flicker like restless fireflies. They appear, vanish, reappear, tiny rebels against the rigid laws we thought defined reality. Here in the quantum abyss, certainty dissolves. An electron refuses to occupy a single place, drifting as a cloud of probabilities, as if undecided about whether it even wishes to exist. A photon travels like a wave until the very moment we dare to observe it, when it collapses into a single, measurable particle, as though the universe waits for our gaze to choose its shape. These are not the tricks of illusionists. They are the fundamental behaviors of the building blocks of everything we know. For centuries, science has been our lantern in the dark, a promise that reason can map the hidden architecture of reality. Yet quantum physics is not merely a map. It is a riddle written in symbols of uncertainty. It whispers that the cosmos is not the cold clockwork machine our ancestors imagined, but a restless dream whose edges blur when we try to touch them. Consider the double-slit experiment. A beam of light, fired through two narrow openings, forms an interference pattern, as though the particles are waves exploring every possible path at once. But the moment we place a detector to watch, the pattern collapses and the photons march obediently through one slit or the other. The simple act of observation reshapes the outcome. Are we witnessing a trick of measurement or an intimate dialogue between consciousness and matter? Galileo taught us to trust the evidence of mathematics and experiment. Quantum mechanics dares us to question whether evidence itself is shaped by the observer. If reality can bend beneath the weight of a mere glance, what becomes of the notion that the universe exists independent of our minds? Across the cosmic scale, the contrast sharpens. The Milky Way spins in grand, patient arcs. Nebulae drift like slow-moving storms of light and dust, sculpting stars that will burn for billions of years. Gravity knits these structures together with quiet authority. On this scale, the universe feels solid, eternal, indifferent to our fleeting thoughts. Yet, at the smallest scales, existence behaves like a fevered dream particle, entangled across light years, sharing information instantaneously as if space itself were an afterthought. Science seeks the measurable. Philosophy hunts the meaning. Between them lies a question that refuses to stay silent. Is the universe a physical edifice of matter, or a theater where consciousness itself paints the scenery? Perhaps what we call reality is less like a stone cathedral and more like a melody that only exists when heard. Physicists like Niels Bohr and Werner Heisenberg once argued late into the night about whether particles have properties before we measure them, or whether those properties arise only in the act of measurement. Decades later, their debate still echoes through laboratories and lecture halls. The equations work, the predictions hold, yet behind the precision hides an unsettling possibility: that the cosmos we explore is not merely discovered, but also somehow created in the very act of exploration. We stand then at a threshold. On one side lies the comfort of classical certainty, a universe of stars and stones governed by forces that need no witness. On the other side stretches a quantum landscape where observation and existence intertwine like dancers in an unseen ballet. Which is the truer reality? And if both are true, what does that say about the role of our own awareness? Perhaps we are not mere spectators, but participants in a grander story than we dare imagine. Perhaps the galaxies swirling above and the particles flickering below are not separate realms at all, but two verses of a single, unending poem. Foundations of Quantum Reality Imagine standing at the edge of a vast ocean at night. The moonlight scatters across the waves, and for a fleeting instant you cannot tell whether the water is a solid sheet of silver or a field of restless particles. Quantum mechanics invites us into a similar twilight where nature refuses to be neatly defined. Here, reality itself trembles between certainty and possibility, daring us to question every instinct about how the world should behave. Classical physics once seemed like a fortress of reason. Newton's laws promised a universe ruled by clockwork determinism. If you knew the position and momentum of every particle, you could, in principle, predict the entire future. It was a comforting vision, a cosmic ledger balanced by cause and effect. But in the early 20th century, a series of startling discoveries cracked that fortress open. At the smallest scales, nature began to whisper a different language, one of probability, ambiguity, and mystery. At the heart of this revolution lies the principle of wave-particle duality. Light, which for centuries had been treated as a continuous wave, suddenly revealed a split personality. In experiments by Albert Einstein and others, light sometimes behaved like discrete quanta, tiny packets of energy called photons capable of knocking electrons loose as if they were microscopic bullets. Yet in other settings it spread and rippled like a wave across the void. Matter itself, once thought to be made of indivisible atoms, shared this strange duplicity. Electrons could diffract and interfere as though they were waves of possibility rather than point-like particles. Nature, it seemed, wore a mask with two faces, and which face we saw depended on how we chose to look. Nowhere is this tension more dramatically staged than in the double-slit experiment. Picture a simple barrier with two narrow openings and a screen behind it. Fire a stream of electrons one by one through the slits. Intuition suggests that each electron will pass through either the left slit or the right slit, striking the screen and gradually forming two piles. Yet astonishingly, the pattern that emerges is an interference pattern, the kind produced by overlapping waves. Each individual electron behaves as if it travels through both slits simultaneously, its position described not by a definite path but by a wave of probabilities. Only when we place a detector to observe which slit it takes does the interference vanish, and the electrons suddenly behave like ordinary particles. Observation itself alters the outcome, as though the universe is sensitive to the mere fact of being watched. This is the riddle of superposition, the idea that a quantum system can exist in multiple states at once until measurement forces a choice. Schrödinger's famous thought experiment sharpened this enigma. A cat sealed in a box with a radioactive atom is neither alive nor dead until someone opens the lid. It is not that the cat is secretly one or the other, and we simply lack knowledge. The theory insists that before observation, the system genuinely occupies a hybrid of possibilities. Reality at the quantum level is not a fixed story waiting to be read. It is a script still being written. Entanglement deepens the strangeness. When two particles interact and then separate, their properties can remain mysteriously linked, so that measuring one instantly determines the state of the other, no matter how far apart they may be. Einstein called it spooky action at a distance, suspecting that hidden variables must lurk beneath the surface. Yet decades of experiments, most notably the tests of Bell's inequalities, have confirmed the effect beyond reasonable doubt. The universe, it appears, permits connections that defy classical logic, as if distant pieces of reality share an invisible thread. These revelations pit mathematical precision against philosophical mystery. The equations of quantum mechanics are among the most accurate in all of science. They predict the behavior of particles and the spectra of atoms with breathtaking fidelity. Yet what those equations mean remains elusive. Do the probabilities reflect a deep indeterminacy in nature itself, or merely our limited knowledge? Does the act of measurement create reality, or simply reveal it? Physicists debate interpretations from the many worlds view, where every outcome unfolds in parallel universes, to the pilot wave theory that hides a deeper deterministic order. Each interpretation captures part of the truth, yet none commands unanimous acceptance. The quantum eraser experiment twists the knife further. Here, scientists have shown that information about which path a particle takes can be erased after it has already traveled, and the interference pattern can be restored as if the particle retroactively decided to behave like a wave. Cause and effect blur, and our everyday notions of time and sequence begin to wobble. Imagine staring into a night sky so black it feels infinite, the stars like silent witnesses scattered across a cosmic canvas. For centuries, we believed those distant points of light existed whether we watched them or not, their orbits and fates untouched by our gaze. But quantum physics whispers a more unsettling possibility, that the very act of looking may not merely reveal reality, it may create it. At the heart of this enigma lies the observer effect, a phenomenon that refuses to stay politely within the boundaries of classical science. In the subatomic world, particles do not march predictably like tiny billiard balls. They shimmer in a haze of probability, described not by definite locations but by a wave function, a mathematical cloud of possibilities. Before we measure them, electrons do not occupy a single spot. They inhabit a spectrum of potential states, a restless ambiguity that defies our everyday intuition. Yet the instant we observe, that haze collapses. The particle chooses. The universe, for a fleeting moment, seems to bow to our attention. It was this revelation that startled the pioneers of quantum theory in the early 20th century. Niels Bohr and his colleagues, wrestling with the strange outcomes of the double-slit experiment, proposed what came to be known as the Copenhagen interpretation. According to Bohr, reality at the quantum level is not a fixed stage waiting for discovery. Instead, the very properties of a particle, its position and its momentum, are not real until they are measured. Observation is not passive, it is an act of creation. The wave function, a delicate superposition of all possible outcomes, collapses when a measurement occurs, leaving behind a single, concrete fact. This is the observer's paradox. The universe seems to require a witness, yet the witness is part of the universe. How can the act of looking transform what is looked upon? Does the cosmos, at its most fundamental layer, depend on consciousness to solidify its own existence? Not all physicists were comfortable with this suggestion. Albert Einstein famously protested, "Do you really believe the moon is not there when you are not looking at it?" For Einstein, reality had to be independent of human perception, and the notion that our observation could conjure existence felt like mysticism disguised as science. His skepticism gave birth to decades of debate, experiments, and rival interpretations that continue to shape the philosophy of physics. One such rival is the many worlds hypothesis, championed by Hugh Everett in the 1950s. Rather than collapsing possibilities into one, Everett's vision lets them all live on. Each time a quantum event occurs, the universe branches. Every potential outcome is realized, but in different, non-communicating worlds. In this view, when you measure an electron, you do not force it into a single destiny. Instead, reality splits. There is a version of you who found the particle spinning up, and another who found it spinning down, both equally real, both forever, beyond each other's reach. This interpretation sidesteps the mysterious collapse of the wave function by denying that collapse happens at all. It offers a cold, austere elegance. The laws of quantum mechanics unfold deterministically across an infinite multiverse. Yet it also raises staggering questions. If every possibility is real somewhere, what does individuality mean? What becomes of free will when each choice is merely one branch among countless duplicates? The many worlds hypothesis replaces the magic of collapse with the vertigo of infinity. Others sought refuge in a more hidden order. Louis de Broglie and later David Bohm proposed the pilot wave theory, in which particles possess definite positions at all times, guided by an invisible pilot wave. Here, the The apparent randomness of quantum outcomes masks a deeper deterministic dance. Measurement does not conjure reality. It merely uncovers a pattern already woven into the fabric of existence. Bohm's universe is one of profound connectivity, where every particle is subtly linked to every other, an implicit order humming beneath the visible world. Between these interpretations, Copenhagen's conscious collapse, Everett's branching multiverse, Bohm's hidden pilot waves, lies a chasm of philosophical tension. Each explanation is supported by the same mathematics, yet each tells a radically different story about the nature of being. Is reality a single fragile thread, spun only when we look? Is it an infinite tapestry of parallel worlds, each as real as the next? Or is it a vast, concealed mechanism whose inner workings we have barely begun to glimpse? Consciousness at the edge of physics. For centuries, physics has stretched its reach from the movements of planets to the flicker of subatomic particles. Yet when the gaze turns inward to the very experience of being, our most elegant equations grow strangely silent. Consciousness, the shimmering fact of awareness itself, hovers at the edge of scientific description like a mirage. We can measure the speed of light with unerring precision, trace the evolution of stars, and even glimpse the birth of the universe, but the simple certainty that you are aware right now remains the most stubborn mystery. What is the nature of the eye that observes the cosmos? Is it merely an emergent property of biological complexity, or does it tap into something more profound, something that might rewrite our understanding of reality? This question has lured some of the greatest scientific minds toward a bold frontier where physics and philosophy blur. Among them stands Sir Roger Penrose, a mathematical physicist whose work on black holes earned him a Nobel Prize. Penrose is no casual dreamer. His reputation rests on rigorous geometry and deep insights into the structure of space-time. Yet he has long maintained that the mystery of consciousness cannot be solved by the conventional methods of neuroscience or computational theory. According to him, the spark of subjective experience cannot arise from neurons firing like mechanical switches. Something else fundamentally non-algorithmic must be at play. Enter Stuart Hameroff, an anesthesiologist fascinated by how chemicals can so abruptly switch awareness off and on. Together, Penrose and Hameroff crafted a daring hypothesis, the orchestrated objective reduction, or OR model. It proposes that the mind's most intimate theater conscious thought emerges from quantum processes inside tiny structures within our brain cells known as microtubules. These microscopic scaffolds, traditionally seen as mere structural supports, become in their vision delicate arenas where quantum states could form, entangle, and collapse. The moment of collapse, the objective reduction, would not be random but orchestrated by biological systems, producing the flashes of awareness we recognize as consciousness. To Penrose and Hameroff, the usual story of classical neurons passing electrochemical signals like a digital circuit misses the very essence of subjective life. Computation alone, they argue, cannot generate the ineffable quality of experience, the redness of red, the pang of nostalgia, the taste of morning coffee. Instead, they suggest that consciousness springs from fundamental physics itself, that the collapse of a quantum wave function is not merely a mathematical abstraction, but a real, physical event, and that our minds are somehow riding on this profound level of nature. It is a vision both dazzling and unsettling. If true, it would mean that consciousness is not simply a byproduct of brain chemistry, but a phenomenon woven into the fabric of the universe. The human mind would not merely observe quantum reality, it would participate in it. The divide between subject and object, between inner thought and outer world, would blur into something far more mysterious. But as with all provocative ideas, OR has met fierce resistance. Many neuroscientists and physicists argue that the brain is far too warm, wet, and noisy to sustain delicate quantum states. Quantum coherence. Those fragile entanglements of particles typically survive only at near absolute zero in carefully shielded laboratories. How, skeptics ask, could the bustling biochemical environment of the brain nurture such subtle phenomena? Max Tegmark, a physicist known for his work on the mathematical structure of reality, performed calculations suggesting that quantum coherence in microtubules would decohere in less than a trillionth of a second, far too brief to influence the millisecond scale operations of neurons. For many researchers, this seemed like a death blow, a sobering reminder that while quantum mechanics is wondrous, not every wonder belongs in the biology of thought. Neuroscience, too, provides compelling counterpoints. Decades of research map conscious states to patterns of electrical activity in networks of neurons. From anesthetic studies to brain lesion data, the evidence supports consciousness as an emergent property of classical computation, a dynamic pattern of firing neurons, not quantum fluctuations. The brain's complexity, they argue, is vast enough to generate subjective experience without invoking exotic physics, and yet the debate refuses to die. Penrose and Hameroff have countered that microtubules might be more resilient than Tegmark calculated, perhaps capable of shielding quantum states in ways we do not yet understand. Recent studies have found unexpected quantum effects in biological systems from photosynthesis to bird navigation, hinting that life may indeed exploit quantum phenomena in surprising ways. If plants and birds can harness quantum coherence, why not neurons? This tension between the skeptical weight of established neuroscience and the tantalizing hints of quantum biology creates a dramatic crossroads. On one side, the solid ground of evidence, neurons, synapses, electrochemical signals, all painstakingly mapped and measured. On the other hand, the vertiginous possibility that consciousness is not just an emergent computation, but a fundamental feature of the universe itself, one that touches the same deep reality that gives rise to stars and galaxies. For those drawn to the grandest questions, the allure is irresistible. If Orsh or any quantum theory of mind were validated, it would collapse the barrier between physics and the inner life of awareness. Consciousness would not be a late evolutionary accident, but a cosmic principle woven into the very mathematics of existence. The implications would ripple far beyond science into philosophy, spirituality, even the way we conceive of life and death. Still, caution whispers from the sidelines. History is littered with seductive ideas that faltered when tested against nature. The burden of proof remains immense, and yet, even skeptics admit that consciousness remains one of science's deepest enigmas. We can chart the neural correlates of perception, but the leap from electrical patterns to the feeling of experiencing the so-called hard problem of consciousness remains unresolved. Perhaps, then, the true value of the quantum mind hypothesis lies not in immediate answers, but in the way it forces us to confront the limits of our understanding. Whether quantum mechanics ultimately explains awareness or not, it challenges us to reconsider what we mean by reality itself. The same equations that describe particles dancing in a vacuum might, in some hidden way, resonate with the very fact of our own sentience. Here, at the edge of physics and mind, science and mystery entwine. Consciousness stands as a mirror to the universe, reflecting not only what we know, but the vastness of what we do not. Whether the key lies in neurons or quantum waves, in algorithms or something beyond computation, the search itself reveals the profound depth of the human quest. To understand not merely the cosmos we inhabit, but the very awareness by which we behold it, simulation or dream. Competing cosmic theories, 1/500 words. What if the world you touch, the sky you gaze upon, the very thoughts passing through your mind, are no more solid than the pixels of a video game or the flicker of a dream? What if the ultimate nature of existence is neither matter nor energy, but a grand illusion, an architecture of code or a tapestry of consciousness? This is not merely a late-night musing. It is a question that unites cutting-edge philosophy with ancient spiritual insight, and it forces us to confront a disquieting possibility. Everything we call reality might be nothing more than a simulation or a dream. In the early 2000s, philosopher Nick Bostrom sharpened this idea into an argument that has become one of the most provocative of our time. His simulation hypothesis does not begin with mysticism but with cold logic. Consider the relentless march of technology. Within a few centuries, perhaps far sooner, civilizations may possess computers powerful enough to simulate entire worlds, complete with conscious beings who believe they are real. If such simulations are possible, Bostrom argues, then one of three statements must be true. Either civilizations never reach that technological maturity, or they reach it but have no interest in running simulations, or they do run them, and if they do, the number of simulated minds would vastly outnumber those in base reality. If the third option holds, the odds tilt dramatically toward the unsettling conclusion that we are among the simulated. The argument is not science fiction. It is a sober piece of probability theory that has unsettled philosophers and physicists alike. Evidence, in the strict sense, is hard to come by, yet tantalizing hints surface in unexpected places. Quantum physics, with its indeterminate particles and sudden collapses, sometimes feels eerily like a digital rendering updating itself only when observed. The Planck length, the smallest meaningful unit of space, suggests a kind of pixel size to the universe. Some physicists, like the late John Archibald Wheeler, have even mused that reality might be fundamentally information it from bit, as he famously put it. For believers in the simulation hypothesis, these coincidences are more than poetic. They are clues that the cosmos might be a vast computational construct. But to imagine the universe as code is to imagine a coder. If we are simulations, who built the machine? Are our creators scientists in some unimaginable future, running ancestral simulations to study their own origins? Could they be beings so advanced that our entire cosmos is no more than a line of code in their grand experiment? And what of our sense of self? If our memories and emotions are data, does that make them less real or simply real in a different way? The hypothesis unsettles our instinctive confidence that reality is self-existent. It replaces the solid ground beneath our feet with a lattice of probabilities and programs. Yet centuries before Bostrom, spiritual traditions around the world voiced a strikingly similar intuition. Long before the age of computers, Hindu philosophers spoke of Maya, the cosmic illusion, in which the phenomenal world is but a dream of the divine. The Advaita Vedanta tradition teaches that the ultimate reality, Brahman, is pure consciousness, and that the multiplicity of forms we experience is like a dream that vanishes upon awakening. In Buddhism, the metaphor of life as a dream is equally central. The Heart Sutra proclaims that form is emptiness and emptiness is form, reminding us that the solidity of the world is a construction of perception, not an ultimate fact. In Taoist texts, sages compare existence to the fleeting images of a dream. And in Western mysticism, from Plato's allegory of the cave to the Gnostic vision of a false world, echoes of this idea reverberate. What we take as real might be a shadow, a veil, a story told by something beyond. Unlike the simulation hypothesis, these traditions do not speak of silicon processors or lines of code. Their language is one of spirit and awakening. If the world is a dream, it is not the dream of future technologists, but of consciousness itself, perhaps divine, perhaps collective. The purpose of life, in these teachings, is not to locate a hidden programmer, but to awaken from identification with the dream and recognize the boundless awareness that underlies it. Here too, the self is not what it seems. We are not isolated egos, but expressions of a larger mind, a cosmic imagination that we mistake for material reality. It is tempting to draw a bright line between these two visions, the technological and the mystical, but they are less enemies than mirror images. Bostrom's hypothesis speaks the language of rationalism, probabilities, and computing power. The traditions of Maya and dreams speak the language of metaphor and transcendence. Yet both invite us to doubt the naive realism of everyday life. Both whisper that what we see and touch may not be the ultimate truth. And both provoke the same existential shiver. If this is not the final reality, what is? Critics of the simulation argument point out that it is, in some sense, unfalsifiable. If our universe were a simulation, any evidence we might find could itself be part of the simulation. The hypothesis can explain any observation, which means it predicts none uniquely a classic philosophical catch-22. Others argue that the immense computational resources required to simulate an entire cosmos down to the quantum level would be prohibitive, even for an advanced civilization. Perhaps reality is analog, not digital, and cannot be captured by bits of code. These objections, while powerful, do not dispel the eerie resonance between Bostrom's logic and the spiritual idea of cosmic illusion. Similarly, the dreamlike visions of mysticism face their own challenges. Skeptics demand more than poetic metaphor. If the world is consciousness dreaming, why does it obey such consistent physical laws? Why do independent observers agree on the same reality? The mystics respond that dreams too have inner coherence while they last, and that awakening to ultimate reality is not a matter of empirical proof, but of direct experience. For them, the persistence of the world's patterns does not prove its ultimate solidity. It proves only the depth and intricacy of the dream. The tension between these two narratives, simulation and dream, reflects a deeper question about the nature of mind and matter. In the simulation view, consciousness is an emergent property of information processing. In the dream view, consciousness is primary, and matter is the illusion. The first assumes that mind arises from code. The second, that code, if it exists at all, arises from mind. One sees consciousness as the last product of a vast computational universe. The other sees the universe itself as consciousness unfolding. These are not merely competing theories, they are rival metaphysics, each demanding a different picture of what we are. And yet, in the strange light of quantum physics and information theory, the boundary blurs. If reality is information at its core, as Wheeler suggested, is that so different from saying it is thought? If the ultimate substrate of the universe is not matter, but bits or perhaps qubits, are we not approaching the mystic's insight from a different angle? The language differs, but the implication converges. The foundation of existence is not solid stuff, but something more abstract, more elusive, more like mind. This convergence has not gone unnoticed. Some contemporary philosophers and physicists speculate that the two visions might be complementary rather than contradictory. Perhaps our universe is indeed a kind of simulation, but the computer is not a machine in the usual sense. Perhaps it is consciousness itself, a self-simulating awareness that dreams worlds into being. Here, the technological metaphor and the mystical metaphor meet not as competitors, but as different windows on the same ineffable mystery. For the seeker of truth, the question becomes personal. If reality is a simulation, our lives are lines of code. Yet our experiences, our loves, our sorrows remain undeniably vivid. Does their origin in code diminish their meaning? If reality is a dream, then the self we cling to is a temporary role in a cosmic play. Does this revelation free us or terrify us? In both visions, the familiar boundaries dissolve. The bedrock of certainty crumbles, and in that vertigo lies a peculiar liberation. When reality itself is up for debate, we are invited to look beyond appearances, to wonder not just what is real, but why the question matters. Whether we are algorithms or archetypes in a divine imagination, the mystery remains intact. The simulation hypothesis and the dream of Maya are not merely stories about the universe. They are mirrors held up to the human hunger for meaning. One speaks in the dialect of science, the other in the poetry of spirit. Both remind us that the world we inhabit may be stranger and more fluid than our senses can grasp. And as we contemplate these competing cosmic theories, we find ourselves drawn into the oldest of philosophical riddles, the nature of reality, and the hidden source from which it springs. Ancient wisdom and modern physics step back from the glare of laboratory lights and enter the quiet echo of temple halls, where incense once curled upward like questions without end. Long before quarks and quantum fields entered human vocabulary, sages and philosophers peered into the same mystery that now stares back from our particle accelerators. They spoke in hymns and riddles, but the heartbeat of their inquiry is astonishingly familiar. What is reality, and how deep does illusion run? Across the ancient Indian subcontinent, the seers of Vedanta whispered of Maya, a cosmic mirage veiling the ultimate truth. To them, the world of form and change was a shimmering surface, a theatre of appearances concealing the undivided essence of Brahman. Centuries later, in the quiet cloisters of Buddhist monasteries, teachers of the Madhyamaka school described shunyata, the great emptiness. They claimed that all phenomena arise only in dependence upon one another. Nothing possesses an independent core. And far to the west, Plato gazed beyond the flickering shadows of his allegorical cave, urging us to look past the world of mutable things toward eternal, perfect forms. These visions emerged in cultures separated by geography and language, yet they share a striking conviction: the solid world we cling to is not what it seems. Matter and permanence are, in some sense, a grand deception. Now pivot from incense to silicon, from chanting to the hum of superconducting magnets. Modern physics, armed with mathematics and machines, has peeled open nature's deepest layers, and the revelations echo with uncanny resonance. Quantum mechanics tells us that particles have no definite properties until they are observed. Their existence is a haze of probabilities, a field of potential rather than a fixed fact. The observer is not a passive witness but a participant in the unfolding of reality. Measurement does not merely reveal what is there, it helps bring it into being. This is no mystical metaphor, but the backbone of experimental evidence, the double-slit experiment where electrons behave like waves until watched, then crystallize into particles, the entanglement phenomena where separated particles influence each other instantaneously, as if space itself were an illusion. Here, the boundary between subject and object begins to blur, as if physics has circled back to the ancient intuition that reality depends on perception. Yet the parallel is not a simple mirror. Vedanta's Maya is not quantum uncertainty dressed in Sanskrit. The Buddha's emptiness is not a footnote to Heisenberg's principle. These traditions and theories differ in origin, method, and purpose. Ancient philosophers pursued liberation of the mind. Modern physicists chase predictive power and technological mastery. But in the tension between their goals lies a dazzling insight. Truth wears many dialects. Consider the way both camps dismantle the notion of a solid, unchanging self. In Buddhist thought, the I is a bundle of processes of sensation, perception, consciousness without a permanent core. In quantum theory, the idea of an observer independent of the observed dissolves. Every act of measurement entangles the measurer with the measured. The self becomes not a fixed point, but a relation, a dance of interactions. Or look at Plato's forms abstract ideals more real than the shadows we see. Modern physics, with its invisible equations and symmetries, also posits a realm beyond direct perception. We never see a wave function or a quantum field. We infer their existence through patterns of experiment, much as Plato inferred the reality of perfect geometries from imperfect earthly shapes. The mathematician's equation and the philosopher's form both claim an unseen order beneath the sensory flux. This intellectual consonance raises a provocative question. Are these echoes mere coincidence, or do they hint at something universal in the human quest for understanding? When minds, separated by millennia, converge on the suspicion that reality is more idea than object, it suggests that the mystery is not cultural but cosmic. Of course, science demands evidence, and philosophy thrives on contemplation. Their methods may diverge, but they often illuminate each other's blind spots. Ancient wisdom offers metaphors that rescue physics from sterile equations, while physics lends precision that tests the reach of timeless intuitions. Between them stretches a bridge not of doctrine, but of wonder. Through that bridge, the very act of inquiry becomes a kind of communion, a recognition that our thirst to know is itself a force as real as gravity. And in that recognition, we begin to sense that the universe is not merely a stage for human curiosity, but perhaps a partner in the dialogue. The search for proof has always been humanity's proudest banner. From the first astronomers charting the night sky to the particle physicists plumbing the subatomic depths, we have built our confidence on a single conviction that the world can be measured, tested, and known. Yet when the question turns toward reality itself, toward the possibility that existence is no more than an immense act of imagination, that conviction trembles. How do you measure a dream while you are still dreaming? How do you catch the very substance of consciousness in a net of data when the net is itself woven of thought? Science was forged as a rebellion against mystery. It gave us telescopes and accelerators, controlled experiments and equations as sharp as a blade. Its triumphs are undeniable: the double helix of DNA, the map of the cosmic microwave background, the quantum mechanics that allows us to bend light and compute with atoms. Each discovery whispers the same reassurance that truth can be coaxed from the dark, if only we gather enough evidence. But here lies the dilemma. When the very stage on which evidence appears might itself be an illusion, where do you plant the instruments of inquiry? What laboratory can hold the totality of being when even space and time could be the mind's invention? Philosophers have wrestled with this paradox for centuries. Descartes doubted everything except the bare fact of doubting, a solitary "I think, therefore I am," surrounded by the suspicion that all else could be the trick of a deceiving demon. Berkeley declared that to be is to be perceived, that the apple exists only as sensation in the mind of God. Modern idealists recast the universe as a vast computation of consciousness, while some physicists flirt with the notion that information, not matter, is the primal substance. These ideas shimmer with intellectual daring, but they leave us grasping for something stubborn, something that cannot be swept away by clever language. We long for an experiment, a number, a measurement that will not vanish when the mind closes its eyes. Consider the instruments of modern science. They are themselves products of consciousness, microscopes conceived in thought, detectors assembled by human hands, data interpreted by the brain's silent symphony. Every measurement is an event in awareness. We often imagine that these instruments reveal a reality beyond us, but they are also mirrors reflecting the very act of observation. The Heisenberg uncertainty principle, born in the furnace of quantum mechanics, tells us that the observer and the observed cannot be cleanly separated. Measurement disturbs the measured. For some, this is a technical limitation, a quirk of the microscopic world. For others, it hints at something deeper. Perhaps the universe is not a machine waiting to be watched, but a story that requires a witness to unfold. And yet, skepticism demands more than poetic suggestion. The scientific method thrives on what can be repeated and falsified. A hypothesis must risk failure. An experiment must yield results independent of belief. If reality is merely imagined, who or what performs the imagining? How would we distinguish between a cosmos born of neurons and one conjured by some universal mind? Without criteria for disproof, even the most dazzling theory drifts toward metaphysics. Evidence, by definition, must stand outside the claim it supports. But if all is imagination, there is no outside. The court of reason becomes both judge and defendant, a hall of mirrors without exit. This tension breeds both wonder and unease. On one side, the rigor of physics, the LHC smashing protons to glimpse particles that vanish in trillionths of a second, the James Webb Space Telescope capturing photons that have traveled since the birth of stars. On the other side, the ineffable interior, the fact that you, right now, are aware, that this awareness cannot be plotted on a graph or reduced to equations without losing its essence. Neuroscience maps the neural correlates of consciousness, but the subjective glow of experience, the redness of red, the taste of memory remains a mystery that no PET scan can quantify. We are left straddling two worlds, the measurable and the felt, each undeniable, neither fully explaining the other. Some propose thought experiments as bridges across the gap. Could a sufficiently advanced computer simulate not only the physical universe but also the illusion of selfhood within it? If we discovered that our memories, perceptions, and even doubts were lines of code, would that be evidence of imagination or merely another layer of reality to question? Nick Bostrom's simulation argument teases this possibility, suggesting that if civilizations can create convincing virtual worlds, then statistically we are likely living in one. But even if we could point to the fingerprints of our cosmic programmers, would that settle the question? A simulation can be as real to its inhabitants as any universe. The dream does not cease to be a dream simply because we name the dreamer. Others look inward, arguing that the very act of awareness is the only undeniable fact. Mystics and contemplatives across traditions have claimed that consciousness precedes and contains the cosmos. To them, the problem of evidence is itself misplaced. You do not prove the screen on which the movie plays. The screen is the precondition of every proof. Yet even this insight resists verification. One person's revelation is another's anecdote. A vision may transform the heart, but it does not satisfy the physicist's demand for reproducibility. Between empirical certainty and private illumination yawns a chasm that neither side has yet crossed. This impasse is not merely academic. It touches the deepest human hunger, the need to know what we are and whether our existence carries meaning. We crave certainty as the sailor craves the North Star, something fixed in a shifting sea. But the cosmos answers with ambiguity. Quantum theory reveals a world where particles flicker between possibilities until observed, where causality itself bends under the weight of probability, and consciousness remains a riddle, both the source of every observation and the one phenomenon that refuses to be fully observed. We are explorers searching for a map, only to discover that we are made of the very paper we are trying to chart. Yet this uncertainty is not barren. It sparks the very wonder that drives both science and philosophy. The absence of final proof does not silence inquiry, it deepens it. Like the negative space in a great painting, the unknown gives shape to the known. The limitations of evidence remind us that knowledge is not a fortress but a frontier, a place where the mind meets what it cannot yet contain. Perhaps the value of the question lies not in its answer but in the transformation it demands humility before the vastness of what is. Imagine standing beneath a night sky unpolluted by city lights. The stars blaze with ancient fire, each one a sun, each sun a mystery. Our telescopes capture their spectra, our equations predict their fates, and still something eludes us. The silent presence of the universe contemplating itself through human eyes. Whether reality is the play of particles or the dream of a cosmic mind, the experience of wonder remains. And in that wonder, we glimpse a truth that defies both confirmation and denial. The problem of evidence, then, is not merely an obstacle, but an invitation. It challenges us to refine our instruments, to sharpen our logic, and yet to recognize the horizon of our methods. It calls us to balance the cold precision of science with the warm uncertainty of lived experience. Between proof and mystery, between the measurable and the ineffable, our search continues not toward a final answer, but toward a deeper understanding of the question itself. A universe woven from pure mind, a cosmos that bends to the consciousness of its observers. These are visions that stir our deepest curiosity. Yet, in the quiet chambers of academia, not everyone is persuaded. For every tantalizing hypothesis about reality as a simulation or consciousness as the engine of the quantum world, there stands a formidable chorus of skeptics. Their voices are neither dismissive nor hostile. Rather, they are steeled by a devotion to clarity, a commitment to the hard-won discipline of evidence. To understand the full landscape of this debate, we must step into their realm, a domain where wonder must wrestle with reason. The first challenge comes from those who insist that the universe, magnificent and mysterious though it may be, is at its heart a physical system. This view, sometimes called physicalism or materialism, has deep roots. From the ancient atomists to the architects of modern physics, the conviction that reality consists of matter and energy governed by impersonal laws has been the foundation upon which centuries of scientific achievement rest. For the skeptic, every leap toward cosmic consciousness risks unmooring us from this proven ground. They argue that while human understanding is incomplete, that gap is not an invitation to metaphysical speculation, but a call for better experiments, sharper theories, and patience. Consider the case against simulation theory, a notion that has seeped from philosophy seminars into the pop culture bloodstream. The claim is seductively simple. If future civilizations can simulate consciousness, and if such simulations are cheaper to run than universes are to build, then statistically, we are more likely to be inside one of those simulations than in base reality. Yet philosophers like David Chalmers and physicists like Sabine Hossenfelder point out that this argument hinges on untested assumptions. It presumes an infinite computational capacity and a future species both capable and willing to replicate the staggering complexity of a cosmos. We barely understand consciousness itself, let alone how to encode it. Why believe that an advanced civilization would devote unimaginable resources to constructing an elaborate, undetectable theater just to trick its inhabitants? For the skeptic, simulation theory can feel less like a sober hypothesis and more like a digital age rebranding of ancient creation myths. Moreover, there is the question of evidence. Nick Bostrom's original formulation was designed to be logically airtight but empirically elusive. A perfect simulation, by definition, would reveal no cracks, no errant pixels, no cosmic software glitches for our instruments to detect. Critics argue that a theory immune to falsification drifts perilously close to metaphysics. Science thrives on predictions that can be tested and potentially refuted. A hypothesis that survives precisely because it offers no such vulnerability, they contend, is not a scientific theory, but a story intriguing. Perhaps even inspiring, but a story nonetheless. Quantum consciousness models fare no better in the skeptical court. The notion that the mind plays a fundamental role in collapsing quantum wave functions has a dramatic allure. Reality itself, waiting in a ghostly superposition, leaping into being only when observed. But then mainstream physicists urge caution. The so-called observer effect, often cited as evidence that consciousness shapes reality, is more precisely a description of how measurement, whether by a human eye or an automated detector, interacts with a quantum system. The wave function does not need a thinking mind to collapse. It needs only an interaction that records information. To mistake this for proof of a conscious cosmos, say critics like Sean Carroll, is to confuse the poetry of metaphor with the rigor of physics. Even more speculative are proposals like the OR theory championed by Roger Penrose and Stuart Hameroff, which suggest that consciousness arises from quantum computations within the microtubules of neurons. The idea is undeniably bold, bridging the chasm between physics and the enigma of the mind. Yet decades of research have yet to produce robust empirical support. Neuroscientists point out that the brain's warm, wet environment is inhospitable to delicate quantum states, which typically require isolation and near absolute zero temperatures to remain coherent. Detractors argue that until such obstacles are overcome with data rather than conjecture, quantum consciousness remains an elegant but unproven dream. Beneath these technical disputes lies a deeper philosophical warning: the danger of anthropocentrism. Throughout history, humans have repeatedly imagined themselves as central to the cosmic drama, whether as the chosen species of divine creation, the pinnacle of evolution, or now perhaps, the ultimate architects of reality itself. The suggestion that our consciousness could be the engine that powers the universe may simply be the latest chapter in this long narrative of self-importance. Skeptics like philosopher Daniel Dennett caution that such ideas risk smuggling ancient hubris into modern science, wrapping old myths in the glittering language of quantum mechanics and computational theory. For these critics, the antidote is humility. The universe is vast beyond measure, its workings governed by laws that operate with or without our awareness. To claim that reality requires our participation, or that it exists primarily to cradle our consciousness, is to inflate the human role to a scale the evidence does not warrant. The fact that our instruments can measure quantum effects or that our brains can imagine simulations does not mean that the cosmos depends on us. Indeed, the very success of science, from predicting eclipses to detecting gravitational waves, rests on the assumption that nature is indifferent to our presence. Skepticism, however, is not cynicism. The most thoughtful critics are not seeking to extinguish wonder, but to channel it. They remind us that mystery is not a vacuum to be hastily filled with speculation, but a frontier to be explored with discipline. When confronted with the unknown, it is tempting to reach for grand explanations. A universe that is a simulation, a consciousness that shapes matter. Yet history teaches caution. Many ideas once thought magical, the motions of planets, the origin of disease, the nature of lightning have yielded to natural explanations when the tools of inquiry matured. The skeptic asks, why should the mysteries of quantum physics or the riddle of consciousness be any different? To underscore their case, they point to the predictive power of established science. The equations of quantum mechanics, though famously counterintuitive, have delivered technologies from lasers to semiconductors with uncanny precision. These successes suggest that the theory, for all its strangeness, is a description of objective reality, not a mirage dependent on human thought. Similarly, neuroscience has mapped cognitive processes with increasing detail, linking mental states to neural activity without recourse to hidden quantum secrets or cosmic minds. While our understanding is far from complete, the trajectory is clear. Explanations rooted in physical law continue to expand, not contract. Critiques of simulation theory also highlight an uncomfortable paradox. If we truly inhabited a simulation, and if the simulators wished to keep it hidden, any attempt to prove or disprove it would be meaningless. Evidence of a simulation would itself be part of the simulation. The absence of evidence would be equally inconclusive. In this light, the hypothesis collapses into a philosophical curiosity, perhaps stimulating for late-night debates, but offering no concrete foothold for science. For the skeptic, this is not just a limitation. It is a disqualification. Some go further, questioning the psychological motives behind such theories. Is the appeal of cosmic consciousness or simulated reality partly a response to existential anxiety, a way to elevate human significance in an indifferent universe? The suspicion is not meant as an insult, but as an insight. Throughout history, when confronted with the vastness of the cosmos and the finality of death, humans have crafted narratives to soften the edges of our mortality. Today's digital or quantum metaphors may simply be the latest evolution of that timeless impulse. Yet even as they dismantle the more extravagant claims, the skeptics acknowledge the persistent magnetism of mystery. No serious scientist believes that we have reached the end of knowledge. Quantum mechanics remains puzzling. Consciousness remains profound. But to leap from mystery to metaphysical certainty is, in their view, a category error. The unknown invites inquiry, not premature conclusion. The proper response to wonder is not dogma, whether scientific or spiritual, but an ever-deepening curiosity tethered to evidence. This skeptical perspective sharpens the narrative not by extinguishing awe, but by refining it. To see the universe as purely physical is not to see it as dull. On the contrary, the fact that impersonal laws give rise to stars, galaxies, life, and minds capable of contemplating their own origins is itself a marvel. The cosmos, indifferent yet intelligible, demands not our belief in hidden architects or quantum souls, but our relentless pursuit of understanding. That, say the skeptics, is wonder enough. And so the dialogue continues between those drawn to cosmic speculation and those anchored in empirical restraint. Their debate is not a battle to be won, but a conversation that enriches both sides. For in the clash between mystery and method, the human spirit finds its truest expression, a yearning for truth, whether the universe is mind, machine, or something beyond our imagining. Cosmic consciousness and the mind of the universe imagine, for a moment, that everything you see, the stars flaring in distant galaxies, the dark silence between them, the invisible wind of particles dancing across the void, might not merely exist, but know that it exists. Imagine the possibility that reality itself, from the smallest quark to the largest cluster of galaxies, is threaded by a subtle awareness. This is not the comfort of myth or the decoration of metaphor. It is the bold and unsettling hypothesis of cosmic consciousness. The idea that the universe might be, in some mysterious sense, a living mind. Throughout history, our species has gazed upward and wondered whether the sky conceals a grand intelligence. Ancient mystics spoke of the anima mundi, the soul of the world, an all-pervading spirit that gives rise to life and thought. But in the modern age of telescopes and particle accelerators, such notions can feel like quaint echoes of a pre-scientific past. And yet, as physics exposes deeper layers of reality quantum weirdness, the holographic fabric of space-time, the strange unity of natural law, an old question stirs with renewed urgency. Could consciousness be more than an accidental spark in human brains? Could it be woven into the universe itself? This daring vision finds one of its most poetic champions in Pierre Teilhard de Chardin, the French Jesuit paleontologist who saw evolution not as blind chaos but as a cosmic pilgrimage toward ever greater complexity and awareness. For Teilhard, matter was not inert. It was the embryonic form of spirit. Across the eons, he believed, the universe is converging toward an omega point, a final blossoming of consciousness in which the mind of the cosmos awakens to itself. His words still tremble with a quiet fire. "We are moving," he wrote, "toward a critical point of collective reflection when the world will find itself organized not only in the structure of matter, but in the very depths of consciousness." To the empirically trained ear, Teilhard's vision may sound less like science and more like a metaphysical dream. But dream or not, it ignites a question that refuses to die. What if mind is not the rare product of matter, but its fundamental character? This question fuels panpsychism, a philosophical view that consciousness is not an emergent property of complexity, but a basic feature of reality, as elemental as mass or charge. Panpsychists suggest that every particle carries some whisper of an infinitesimal mind dust, that when combined, forms the rich inner life we know as consciousness. Critics protest that this is a leap beyond evidence, a poetic guess disguised as philosophy. Where, they ask, is the measurable proof that an electron feels anything at all? Yet panpsychism gains traction not because it is easy, but because it confronts a mystery that science has yet to dissolve, the hard problem of consciousness. How does the dance of neurons give rise to the redness of a sunset, the taste of rain, the ache of longing? To explain subjective experience as nothing but electrochemical signals is to translate poetry into arithmetic and call the music accounted for. Panpsychism flips the question. Instead of asking how matter produces mind, it asks how mind disguises itself as matter. Between Teilhard's omega point and the cool arguments of panpsychists lies a fertile tension between mystical aspiration and analytic rigor. And it is here that physics, unexpectedly, enters the conversation. Quantum theory has long hinted at an inseparability between observer and observed. The act of measurement seems to collapse a cloud of probabilities into a single reality, as though the universe responds to the presence of awareness. Some interpretations caution against taking this literally. The observer effect, they remind us, refers to physical interaction, not human consciousness. Yet, the very need to clarify betrays how haunting the parallel remains. When equations imply that reality is not fully real until something perceives it, even the most cautious physicist must wrestle with the question, what is the role of consciousness in the architecture of the cosmos? Consider the cosmic microwave background, the afterglow of the Big Bang. Its nearly perfect uniformity whispers of a universe governed by deep coherence. Consider the strange fine-tuning of fundamental constants, so delicately balanced that even slight variations would render life impossible. These are not proof of the cosmic mind, but they create a stage on which speculation thrives. Is the universe merely lucky, or is there an intelligence called cosmic consciousness? Call it the mind of the universe quietly shaping the script. Some modern thinkers attempt a synthesis. The philosopher Philip Goff, for instance, defends panpsychism, not as mystical fancy, but as a sober inference. If consciousness cannot be reduced to matter, then perhaps matter itself is conscious at some level. Similarly, physicist David Bohm envisioned an implicate order, a hidden wholeness beneath the visible universe, where mind and matter are two faces of a single reality. In Bohm's view, what we call consciousness may be the universe enfolding and unfolding itself, an unbroken dance of awareness and manifestation. This convergence of ideas, Teilhard's teleological cosmos, Goff's analytic panpsychism, Bohm's implicate order, offers a strange kind of intellectual vertigo. Science demands evidence, philosophy thrives on reason, yet here they brush against something wilder, something that refuses to stay within the lines. Perhaps cosmic consciousness is not a hypothesis to be proved, but an invitation to see differently. What if reality is not a machine indifferent to our presence, but a living conversation, and we ourselves are the universe speaking to itself? Of course, caution is the loyal companion of wonder. To leap from quantum puzzles or evolutionary trajectories to a conscious cosmos risks the same errors that once filled mythologies with capricious gods. It is one thing to marvel at the mystery of mind, another to claim that galaxies think. The line between profound insight and poetic excess is razor-thin, and philosophy must walk it with care. Yet skepticism, too, must guard against dogma. To dismiss the possibility outright is to assume that human concepts of consciousness are the only valid measure of reality's depth. Imagine again the night sky, but this time not as a silent void. Imagine each star as a neuron in an unimaginable brain, each galaxy a network of cosmic thought. The gravitational threads binding clusters of galaxies become like synaptic connections. The dark, energy-driving cosmic expansion pulses like the slow breathing of a universal mind. Whether metaphor or something more, the image unsettles and seduces. It speaks to a primal intuition that we are not strangers in a cold expanse, but participants in a greater life. Such reflections lead inevitably to the question of our own role. If the universe is conscious, if reality itself awakens, what is humanity's place in that awakening? Teilhard envisioned our collective evolution of thought as a critical step, a threshold through which the universe comes to know itself. Panpsychists, less grandiose but no less daring, suggest that our personal awareness is a localized expression of a universal principle. Either way, our own consciousness is not an isolated flame, but part of a vast, unbroken fire. The tension between evidence and speculation, between disciplined skepticism and the yearning for meaning, is the heart of this mystery. Physics gives us equations of astonishing precision, Yet the existence of subjective experience remains an enigma those equations cannot capture. Philosophy offers frameworks of dazzling scope, yet must admit it cannot seal the question with certainty. And so the possibility of cosmic consciousness lingers, neither proved nor disproved, a riddle that invites both awe and humility. Perhaps the universe does not merely contain consciousness. Perhaps it is consciousness, and every star, every atom, every thought is a ripple in its boundless mind. Or perhaps the dream of a sentient cosmos is only our own reflection projected onto the night. Between these possibilities we stand, witnesses to a mystery that is, for now, beyond our final grasp. And it is precisely in that space of unknowing, between the measurable and the ineffable, that wonder takes root, urging us to listen more deeply to the silent music of the cosmos. When physics meets mysticism across the quiet halls of an old European monastery, a small gathering has convened. The scent of burning cedar lingers in the air as a circle of physicists, robes of academia, mingling with the simple garments of contemplatives, sit in hushed anticipation. A Nobel laureate adjusts his glasses. Across from him, a Tibetan monk closes his eyes. The silence is not absence, but invitation. What follows is not a debate, nor merely a symposium. It is a meeting of two great traditions that have, for centuries, circled each other like twin stars, the exacting discipline of physics and the inward, wordless depth of mysticism. This encounter is not a novelty of our century. From the earliest days of quantum theory, pioneers like Niels Bohr and Werner Heisenberg suspected that the subatomic world defied the old mechanical metaphors and called for a different kind of language. Yet the modern dialogue has become far more deliberate. International conferences now bring together theoretical physicists and spiritual teachers, from the Dalai Lama to Christian hermits, to probe the same question from opposite shores. What is the nature of reality when stripped of all appearances? The physicist begins with mathematics, the monk with meditation. One charts particles through equations, the other dissolves the self in silence. On the surface, their tools could not be more different. Yet both strive to pierce the veil to reach that elusive ground where being itself is unveiled. Here, in this rarefied space, science and mysticism stop glaring across a cultural chasm and instead lean toward each other, like two languages attempting a translation of the infinite. The conversation often begins with quantum puzzles that already sound like Zen koans. Consider the particle that exists in a blur of probabilities until measured, or the entangled pair that dances in perfect unison across light years. To the contemplative ear, these are not merely technical curiosities. They echo the ancient insights of non-duality, the intuition that reality is one, that separation is a convenient fiction. The physicist, armed with detectors and supercomputers, presents experimental data. The mystic listens with the knowing of inner experience, nodding as if hearing a familiar melody in a new key. Yet the harmony is never complete. For every bridge, there is a boundary. Science demands verifiable evidence, reproducible results. Mysticism offers truths that are intimate, often ineffable, resistant to the laboratory. A physicist may marvel at the parallels between wave-particle duality and Buddhist emptiness, yet recoil at the suggestion that consciousness itself shapes the universe. A monk may speak of unity beyond time and space, but cannot offer a formula to test it. Their dialogue thrives precisely because of this tension, because neither side can claim the final word. This friction does more than illuminate differences, it sharpens the inquiry. The scientist is reminded that even the most elegant equation is a human construct, not the cosmos itself. The mystic is challenged to articulate experiences that might otherwise remain cloaked in metaphor. Between them emerges a space of mutual humility. Here, doubt is not an enemy, but a companion, and wonder becomes the common ground. From these meetings has grown a subtle but powerful possibility, a worldview in which empirical science and experiential wisdom converge without collapsing into each other. It is not a hybrid that dilutes both, but a dialogue that expands the horizon of understanding. Physicists begin to speak of consciousness not merely as a byproduct of neural chemistry, but as an open question woven into the fabric of reality. Mystics, in turn, find in quantum theory metaphors that resonate with their own revelations, not as proof, but as a parallel hymn. Still, profound uncertainties remain. Quantum mechanics, for all its predictive power, does not explain why the universe is intelligible at all. Mystical traditions, for all their depth, cannot show why inner illumination should map onto cosmic truth. The risk of easy synthesis of declaring science and spirituality two sides of the same coin is the risk of trivializing both. The mystery is not a gap to be filled, but a depth to be honored. It is here, at the edge of knowledge and unknowing, that the dialogue becomes most luminous. The physicist and the mystic meet not to conquer the mystery, but to stand within it, side by side. Their words, like twin beams of light, reveal not a final answer, but the vastness of the question itself. The human experience of the quantum dream. What if the universe is not merely a stage on which we perform, but a dream in which we awaken? The question does not linger only in observatories or physics journals. It drifts into our bedrooms at night, into the silent spaces between heartbeats. For centuries, philosophers have wondered whether reality is fixed, or if it wavers like a mirage. Today, quantum physics, once the domain of cold equations, whispers an unsettling possibility. Perhaps we are more than witnesses to the cosmos. Perhaps we are participants in its very unfolding. To feel the weight of that possibility is to confront two rival stories of existence. In one, we are but characters in someone else's imagination, echoes inside an infinite simulation. Our choices would then be like ripples in a pre-written sea, giving the illusion of freedom while destiny hides behind every wave. In the other, consciousness itself is the sculptor of matter, each thought a subtle chisel stroke on the marble of the real. Between these stories lies a tension as old as human curiosity. The ache to know whether we are marionettes or makers. Listen to the pulse of art across history, and you can hear that tension beating. From the shadowy caves of Lascaux to the trembling notes of Beethoven's late quartets, humanity has long sought to turn mystery into form. These creations are not merely decorations of an indifferent universe. They are the fingerprints of minds reaching toward the infinite. If reality is a quantum dream, then every painting and every poem becomes an act of co-creation. Each brushstroke a declaration that awareness itself shapes the world it beholds. Consider the quiet revelations of personal experience. A woman stands at the edge of a mountain lake at dawn. Mist curls above the surface as the first rays of sun ignite the peaks. For an instant, she cannot tell where her breath ends and the chilled air begins. The moment feels charged, almost electric, a private epiphany that the boundary between observer and observed is porous. Such encounters, often wordless, resonate with the suggestion that consciousness and cosmos are entwined more intimately than our textbooks admit. Yet science demands caution. Quantum mechanics, with its shimmering uncertainties, does not hand us a license for wishful thinking. The equations describe probabilities, not personal destiny. The electron's dance of superposition and collapse is a matter of measurement, not mysticism, at least according to the rigorous language of physics. And still the mystery remains. Observation seems to matter. When an experiment's outcome depends on the act of measurement, the line between knower and known begins to blur. Whether that fact proves consciousness shapes reality or merely reveals the limits of our instruments is a debate that refuses to rest. this uncertainty seeps into our sense of purpose. If existence is the dream of something vaster than ourselves, does morality lose its anchor? Are right and wrong nothing more than the shifting preferences of a cosmic dreamer? Or does the very possibility of co-creation make ethical responsibility even more urgent? To imagine that our awareness helps weave the fabric of the real is to recognize the weight of every choice. The kindness offered to a stranger, the courage to speak an unpopular truth, these acts might ripple beyond what we can see, contributing threads to the quantum tapestry. Cultures across the world have long carried this intuition. In Hindu philosophy, the concept of Maya portrays the world as a divine play of appearances, where ultimate reality is hidden behind the veil of perception. Indigenous creation stories often tell of a universe sung or dreamed into being, where human participation is essential to cosmic balance. Even in the modern West, the Romantic poets sensed that nature and mind were not separate realms but interlaced reflections of a single mystery. These myths and visions, though born in different eras, converge on a shared insight. The human experience is not an accident on the edge of an indifferent void, but a dialogue with something immeasurably larger. In our own century, the dialogue continues in subtler forms. A physicist contemplates the strange harmony between mathematics and nature, wondering why abstract symbols anticipate discoveries long before experiments confirm them. A novelist writes of parallel worlds and the fragile thread of consciousness that connects them. A musician improvises a melody that seems to arise from nowhere, yet feels inevitable. Each of these moments carries a quiet implication that creativity might be more than self-expression. It could be the universe discovering itself through us. If these reflections stir unease, it is because they challenge the comfortable walls of identity. To be a character in another's dream is to question the autonomy we cherish. To be a co-creator is to shoulder a responsibility far greater than we imagined. Either way, the human story is no longer confined to the small theater of personal ambition. We are implicated in a cosmic narrative whose full script remains hidden. Beyond the dream philosophical closure, the night sky has always been our oldest scripture. Long before telescopes ground their glass to precision, before equations etched the grammar of space-time, we stood beneath the stars and wondered what they meant. Tonight, after our long journey through the labyrinth of physics and philosophy, we return to that same primal silence. We have traveled from the measurable to the ineffable, from the cold certainty of mathematical law to the trembling edge of cosmic consciousness. And now, standing at the threshold of all we know and all we cannot know, a question hangs like an unspoken chord. Have we merely described the universe, or have we glimpsed its hidden dream? Science, in its most disciplined form, is a lighthouse against the darkness. It charts the curvature of space, teases out the subatomic tremors of quantum fields, and offers a language of precision where once there was only myth. Yet even the sharpest measurement leaves a margin where mystery seeps through. The more faithfully we map the contours of reality, the more intricate the unknown becomes. Every discovery, whether of black holes or entangled particles, feels less like an end and more like a key to yet another locked door. Our equations do not abolish wonder, they deepen it. Each answer expands the horizon of questions. This is the tension we cannot escape, the human longing for finality against the universe's quiet refusal to provide it. We crave the definitive, the single, elegant explanation that will anchor our existence. But reality seems to revel in ambiguity. Quantum theory whispers that particles exist in multiple states until observed, that certainty itself is a kind of mirage. Cosmology reveals a universe without center or boundary, a stage where time may loop or stretch toward eternity. These are not mere puzzles to be solved. They are reminders that the cosmos is under no obligation to satisfy our hunger for closure. Consider the ancient philosophers who first speculated that the world might be an illusion, a grand play of appearances masking a deeper truth. From Plato's cave to the Vedic notion of Maya, humanity has long entertained the possibility that our senses deceive us. Modern physics, with its counterintuitive revelations, rekindles those old intuitions. When quantum experiments suggest that observation shapes outcome, when the fabric of space and time emerges from something more abstract than matter itself, it is tempting to imagine that reality might be, at some unfathomable level, a thought perhaps even someone else's thought. Yet the temptation to declare it so is precisely what wisdom counsels us to resist. For what is more human than the yearning to know? We are creatures who cannot help but ask why. The stars burn regardless of our questions, yet we look up and demand their meaning. We send probes beyond the solar wind, not only to measure, but to belong. And in this restless seeking, something quietly profound occurs. The act of searching becomes its own revelation. Whether or not the universe is a dream, our desire to understand it is real. That desire is the fire at the heart of every culture, the pulse behind every equation, the silent music of our collective imagination. This is where science and mysticism, so often cast as adversaries, unexpectedly converge. The scientist, guided by evidence, and the mystic, guided by inner vision, both reach toward a reality that exceeds them. One speaks in numbers, the other in symbols, but both confess, at the limits of language, that the ultimate truth is greater than any formula or scripture. The physicist who admits the strangeness of quantum entanglement stands shoulder to shoulder with the poet who feels the cosmos breathe through a single line of verse. Their methods differ, but their awe is the same. And so we find ourselves at an exquisite impasse. We cannot prove that reality is a simulation, nor can we prove that it is not. We cannot demonstrate that consciousness arises from matter, nor that matter is a projection of consciousness. These questions resist final verdict, not because we have failed, but because they may be structured to elude conclusion. Perhaps reality is not a riddle with a single answer, but a symphony of partial revelations, each insight a movement in an unending composition. The music does not resolve. It invites us to keep listening. Humility becomes our most radical form of knowledge. To admit what we do not know is not to surrender, it is to stand honestly before the infinite. In this humility, we glimpse the paradox of our existence. We are small, yet capable of comprehending vastness, finite yet able to conceive the infinite. The same mind that worries over daily routines also contemplates the birth of galaxies. Our thoughts may be brief sparks in cosmic time, yet they illuminate the darkness in ways no star can. Perhaps this is the grandest dream. Not that we inhabit someone else's imagination, but that imagination itself is our bridge to the real. Each theory, each metaphor, each daring leap of speculation is an act of creation, a way of weaving meaning into the fabric of the unknown. When we wonder if the universe dreams through us, we also recognize that we dream the universe into story. Our questions become the very medium by which reality becomes conscious of itself. This is not a defeat of reason. It is its fulfillment. Reason carries us to the edge of mystery, then gestures toward what cannot be reduced to reason alone. The heart beats alongside the mind. Curiosity stands beside reverence. We leave behind the illusion of total certainty and enter a more luminous truth that the quest to understand is itself the source of meaning. The search is not a path to an end. It is the end. It is the cosmic dance in which we are both observer and participant, question and answer, dreamer and dream. So as we close this exploration, we return once more to the silent night sky. The galaxies wheel above, their light traveling millions of years to meet our gaze. Somewhere, a particle flickers between states, neither here nor there, until attention calls it forth. Somewhere, a human heart quickens with the ancient wonder of being alive. Whether or not we dwell inside another's imagination, we dwell within something astonishing. And that perhaps is the deepest truth we will ever touch.